right, one more time. So the mass of the empirical formula is 30, but another experiment showed that the molar mass of the real chemical is 60. You can't be the real chemical. So how many times will this go into that? Twice. So multiply all these by 2, and you get, I get it. Are you okay with this? Now, who won the dollar? Did somebody, you get the dollar? All right. Now, except for peroxides, right? Except for peroxides. And you know what the other exception was? Ooh. What's the other exception? What other ionic compound would it not be already empirical formula? When we were naming compounds, there were only 2 exceptions to the ionic compound rule. One of them was peroxide, because you could have something like this. You could have Na2O2. You normally don't have ionic compounds that are not reduced. Ionic compounds should be empirical formulas, except for peroxides. And what was the other one? What's the name of that compound? Does anybody remember that? Does anybody know the name of this compound? Wow, has it been that long? Okay, that's too much quiet. There's too much quietness. Do you know? This is an exception, wasn't it? Because each chlorine is -1, and you have 2 of them. That's -2. This thing by itself together must be +2, but there's 2 of them. What's this guy called? Mercury 1 chloride. Remember, mercury 1 is a polyatomic ion. Remember, it's Hg2 + 2. Well, anyway, those are the only 2 times an ionic compound would not already be empirical. So, hey, what's the empirical form for that? This one? This one? Okay, how about this one? What's the mass of the empirical formula here? 12 + 1, 13. What if the real chemical had a molar mass of 26? If the empirical had a mass of 13 and the real one had 26, then what's the real chemical? Let's see, 26 divided by 13 is 2. Multiply everything times 2. There we go. I'm not worried about that part. I'm not worried about you going from empirical to molecular. We'll do one of those. So those are easy. So now let's go back to where we were last week. And this is a problem that was in the book. So let's get the book out. And I'll tell you what, everybody has their own style of teaching. And I've been teaching long enough that I figured out certain things, you know. And I figured out one thing is, whenever I was taught this stoichiometry stuff, I know one thing for sure. Either my fault or somebody else's fault, I don't know. I thought there were like 7 different kinds of problems that I had to know how to do. There aren't really that many. But what I was not taught was how to find the common thread on a lot of these. Okay, so I'm going to show you another problem like this one. Okay, so the one we just did, and if you want to, this is on page 223. Did we do this one? Do you remember doing that one? Is that in your notes somewhere? Okay, so here's what it looks like in a book. An oxide of aluminum is formed by the reaction of this many grams of aluminum and this many grams of oxygen. Calculate the empirical formula. Okay, now one more time. You cannot find any kind of formula, unless you're in what world? This is not the mass world, I promise you. This does not mean 2 grams of hydrogen. What does it mean? What does this 2 mean? If I'm in the little world, it means 2 what? 2 atoms of hydrogen combined with 1 atom of oxygen. If I consider this to be a mole of water, it's 2 moles of hydrogen atoms combined with 1 mole. Isn't that right? But either way, what world are you in when you're in a formula world? Am I in the mass world? I'm trying to help you, okay? You guys are fighting me a little bit. What world are you in when you're in the world of formulas? It's not mass. It's a world of number of particles. And what word do you know of that you're sure you're in that world if you're in these kind of units? What's the biggest concept in this whole chapter? Mole. You cannot do this problem if you stay in grams. You must get into the mole world as soon as you can. So here's what we did. Ready? You're going to give me grams of aluminum? I better change it to moles. Is that yes or no? Yes or no? All right, you're going to give me grams of oxygen? I better change it to moles. Now, do you know how to do that with factor label? Okay. Now, here's the hard part. This is not hard to get this number here. But I'm looking at some, I call them ugly-looking numbers. How am I supposed to make ugly-looking numbers look like lowest whole number ratios? Those aren't whole numbers. So what's the math trick? There's a math trick. Get it? You take the smaller of the two. Who's smaller? Me. Divide both of them by the smaller. I'll bet that's going to come out to be 1. You're right. And this came out to be 1.5. Now, at least they don't look as bad, do they? Are we getting close to whole numbers? Now, what do you multiply 1.5 to get a whole number? I'll give you a clue. 1.5 is the same as 3 halves. What if you multiply by the denominator? Wouldn't that do it? 2, multiply by 2. Multiply this by 2 and you get 3. But you had to maintain that ratio. You multiply me by 2, you better multiply me by 2, and then we'll be in the same ratio. Did you know that a 1 to 1.5 ratio is the same as 2 to 3? Oh, there we go. I'm done. This compound, for every 2 aluminums, there'll be 3 oxygens. And that's how I did it. Now, here's what's going to happen to you on the test, I think. You're going to get this far. And then you're going to get these ugly-looking numbers at you, and you'll say, I don't know what to do. Because how many times have you done this in your life? How many times have you taken the smaller of 2 numbers and divided both of them into it? Ever? And that's where you're going to get frozen a little bit. So you'll freeze and say, what do I do now? But the more of these you do, you won't freeze. You'll say, divide by the smaller. All right, let's go to another one. Let's do another one. Okay, this is a little bit trickier. See if you can see this one. Now, I love these questions because they're in the book. And if you want to go home tonight and you said, I think I'm going to try that because that's the only thing I don't know how to do. Does everybody see this problem down here? When a 0.3546 gram sample of vanadium metal is heated in air, it reacts with oxygen to achieve a final mass of 0.6330. Calculate the empirical formula. Now, when I was your age, that would make me kind of nervous. How in the heck do you do a problem like that? But what do you have to do? What's the first thing you have to do? Because right now you're in the gram world. You aren't going to figure out you're not going to figure out any formulas in the gram world. All right, let's try it. I'll give you a minute. I'll give you a minute to try it. Try it without looking at the book. See what happens. Okay, I'm going to put this on pause for 1 minute. I'm going to see how much work you can do in 1 minute. I'll get it. Thank you. Thank you. Okay, let's do it. All right, Ethan, what are you thinking? Do you need to see the problem again?
Yes.
Okay, sorry. All right. If I can teach you to say, I know where I'm at, but I won't be able to, I need to get out of this world into another world, then the ball will get going and you'll be all right. We're also trying to increase our speed at doing problems. So by the time Friday gets here, you can do a lot of problems in that 1 hour. Okay, now, here's the mistake I made, or the teacher wanted me to do it this way. When I was younger, even though I went to college and got this, my mistake was thinking that this problem is so much different than the other one, I had to memorize how to do every kind of problem in the book, like this, in this chapter. And I don't. This can be seen the same way you saw the other one, right? All I need is grams of vanadium and grams of oxygen. Is that correct? And now, and then get out of that world. Get out of the gram world and get into the mole world. And then you're almost home. All right, can everybody stop for a minute? Does everybody have this already ready? Did everybody have this many grams of vanadium? You said, you know what? I can't be in the gram world. I got to get in the mole world. So look up here. And 1 gram of vanadium is, 1 mole is 50.9. 50. What now? Oh, I know what happened. I magnified it. Okay. Now, everybody in here should have said, they're going to give me grams of vanadium. I know I got to change that to moles. Did everybody get that? Okay, now, the other one's a little bit trickier. When they heated this metal in oxygen, did it weigh more or less when they got done? Everybody look at me. This is important. When they heated this metal in air, did it weigh less or more when they got done? And don't guess. It tells you. It says here, when they heat it with oxygen, the final mass was what number? So this right here is how much the vanadium oxygen compound weighed. Do you get it? Okay. But how much did the vanadium weigh? So how much oxygen? See that? I had somebody last year have, I said, hey, I'm going to put you on the bathroom scales. Oh, you weigh 120? Then I say, go out that door and come back. And I had another teacher out there, and they put a backpack on you. You weigh 120. You come back, you stand on the scales. 140? Ah, why do you weigh 140? And how much did the backpack weigh? 20, didn't it? Well, look at here. Here you are. Here's the vanadium. Vanadium, go out there. And you come back, vanadium. How come you weigh more? I got a backpack on me. An oxygen backpack, don't I? So how many grams of oxygen? And last year I got this number. Tell me if I got this right. Is that right? Does everybody see how I subtract? So slip it in here. Hey, get out of the gram world. And how do I get out of the gram world for oxygen? What do you think? Tell me. What am I going to put here? Everybody. 16. All right, put those in there, and I'll bet you're going to get two ugly-looking numbers. And don't ever go below 3 sig figs. You get that? Don't ever go below 3 sig figs. Now, I see what the author had. Tell me if you got the same thing that he did. 0.006. That's the first sig fig. 96. Is that what you got? Now that's 4 sig figs. But even if you got 0.00696, I'd be okay with that. And that's moles of vanadium. And then down here they got 0.0174 moles of oxygen. Is that what you're getting? Okay, so how am I supposed to come up with an empirical formula with these ugly looking numbers looking at me? So what's that math trick that they do to find the lowest whole number ratio? What do they do? Divide both of them by what? By the smaller. Okay. So what do we have? So we have for vanadium, how many moles of vanadium now if we reduce it? Divide this. Do you get 1? I bet you get 1. So there you go. And how many moles of oxygen? What'd you get here? What's 0.0174 divided by 0.006961? I see what the author got. Who can I ask? Noah Ramos. What'd you get? What's this divided by that? What's this divided by that? That's right, 1. What's this divided by that? Have you done this one yet? Yes. Now, we're getting close, aren't we? That looks a lot better than those ugly looking numbers. Now, the empirical is the lowest whole number ratio. So what do I have to do to this number to make it a whole number? But if you multiply him by 2, you have to multiply this times 2. Final answer. For every 2 moles of vanadium, you better have what? 5 moles of oxygen. Final answer. Ready? V2 O 5. Wow, that's pretty neat how that works. All right, ready? Let's see how fast you can do the next one. Let's do right here. Let's do the self-check exercise right there. Do that one. I'll magnify it a little bit. In a lab experiment, it was observed that 0.6884 grams of lead combines with 0.2356 grams of chlorine to form a binary compound. Calculate the empirical formula of this compound. I'm working for speed, okay? We're going a little speed here. Remember, there's 2 kinds of lead chloride. There's lead 2 chloride and lead 4 chloride. Let's figure out which one it is. Working on speed a little bit here. All right. How many of you figured out you had to get out of the gram world into the mole world? Did you figure that out? Okay, now I wrote down from last year that the number of moles of lead was 0.00332. Is that what you had? Something like that. Is that what you had? Now the moles of chlorine were 0.00662. Did you get something like that? Remember, chlorine's 35.5, not 35. Now, I can look right here at those ugly numbers, and I'll bet I can tell you something. What's going to happen if I divide them all by the smaller? What's the first number divided by 0.00332? Isn't that 1? What do you think the second number, divided by the smallest number is? Isn't that 2? So for every one of these, you have to have what? 2 of those. So what's your final answer? PbCl2. What do you think? Next problem. I don't want you to do this one. I want you to look at it, okay? Don't do it. Just look at it. A sample of lead arsenate, an insecticide used against a potato beetle, contains that many grams of lead, that many grams of hydrogen, that many grams of arsenic, and that many grams of oxygen. Oh, how are you going to do that one? And again, when I was your age, even in college, I thought, there's another kind of problem I have to learn how to do. No. What are you going to do with all those grams? Change them all to what? Moles. Okay, let's turn the page. What did the author get? Let's take a look. Whoa. Look at those ugly looking numbers. He took the smallest and divided them all. Don't go below 3 sig figs, okay? And he came out 1 to 1 to 1 to 4. So what's the final formula? PB1, H1, AS1, O4. See how it works? Is that any different? It just had 4 of them instead of just 2 or 3, right? All right, no different. And the last one, and this is going to be it. This is going to be pretty much it. Let's look at it. It says here, look down at sample 8.14. 8.14. Cisplatin is a common name for a platinum compound that's used to treat cancerous tumors. It has a composition by mass of 65.02% platinum, 9.34% nitrogen, blah, 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 blah. All right, now, I'm trying to teach you to think, okay? You're not even in the gram world. We just did 3 problems in a row. Hey, you in the gram world? Get in the mole world. How are you going to get in the gram world? And I'll tell you something most you don't understand. I didn't understand until your age. I'm not saying you're not. You're smart. You're smart. What if I told you that I had this piece of rock, and that rock was 50% was gold, and 50% was oxygen? Yes? What if the rock weighed 500 grams? 500 grams. How many grams of gold would be in there? Let's say it was, I shouldn't say that. Let's say that 80% of it was gold. Let's try it again. It's let's say 1,000, okay? 1,000 grams. 80% of that is gold. Then 800 grams would be gold, wouldn't it? Now, let's cut it in half. Now it's a 500 gram rock. What percent of it is gold now? Now wake up if you're not awake. Ready? 500 grams of it, what percent of it is gold? It's 80%. Let's cut it in half again. Let's cut it into 100 pieces. This little piece of that rock, what percent of that is gold? 80%? Yes? So now, what makes this problem seem hard, but it's not? I'll show you why it's not hard. Any amount of this compound. Hey, how much of this did you give me? How many grams did you give me? Oh, you never told me. You're not going to tell me? I'm going to pick my own number. I think you gave me 100 grams of this sample. Why would you do that? Because I'm not stupid. Why'd you pick 100 grams? You know why? Because if you give me 100 grams of something and 65.02% of it is platinum, then how many grams are platinum out of 100? 65.02? Oh, can you do that? That's like cheating. Let's try it again. I'm going to assume that you gave me a 100-gram sample. Why? Because it makes my life easy. If you give me a 100-gram sample and 65.02% is platinum, then how many grams are platinum out of 100? What's percent mean? Per 100. Oh, I never knew that. How many grams of nitrogen are in that compound? I'll say 9.34% of 100 grams. 9.34 grams? Well, that's cheating. No, it's not cheating. And so, guess what? I get to change all those percents into grams, don't I? And then, wait, I know how to do those kind of problems. If you're in the gram world, get out of the gram world, get in the mole world. And I got some ugly looking numbers. Divide by the smallest. What'd you get? 1, 2, 6, 2. See? And by the way, 1.99 is 2. 2.01 is 2. 1.7 is not 2. 2.3, that's not 2. You did something wrong, okay? What do you think? You guys are very quiet today. You're very quiet. All right, I'm done. The only thing I want to show you, we did this several times. By far, the easiest part of the chapter is right there. Right there. Here we go. A white powder is analyzed and have an empirical formula of, what's that say? Does that say P2O5? Okay, so the empirical formula is P2O5. And then another experiment was done and found out that the molar mass was 283.88. What's the formula of this compound? Okay, number one. What is the mass of the empirical formula? Let's see, 2 phosphorus, 5 oxygen. That comes out to be 142. This weighs 142. Are you the real chemical? Because you weigh 142. No. Another experiment told me that the molar mass was what? Not 142. What was it? 283, right? Well, then how many times will 142 go into that? 2. So take the empirical times 2. What is P2O5 times 2? P4. That's the easiest part of the whole chapter. Now I'm actually done. I'm done teaching the chapter. What I'd like you to do is I'm going to hand you a thing called a certification. There's no huge rush. Matter of fact, you can skip number 1 if you want to. And all I ask you to do is you don't take it home. You only do it here. If you want to use your notes, you can use your notes. You got it? And even if you said, man, I had some little trouble with that certification, well, then you can look up stuff if you want. And then this coming Wednesday, when you come in, you have all period. That's all you do is I walk in a room and try to certify you, and then you try to finish by the end of the day. You got that? If for any reason you're still lagging behind, I'm okay with that. I can actually meet with you on different times, or when everybody else is doing a study test on Thursday, I can finish certifying you if you want. All right. I'm not expecting you to be ready to take the test tomorrow. You get that? I'm not expecting it by Wednesday. I'm expecting it by Friday you can take the test. Can you do that?